So I wanted to talk a little bit more again about correlation coefficients. So we talked about the correlation matrix and how to put together a correlation matrix, but really I wanted to talk about is again I wanted to drill home the principles of what the numbers actually mean. So we have positive relationships, we have negative relationships, and how are those portrayed in correlation coefficients. And I think it's easier, for me at least, it's easier to explain it with a schematic. So what I've done here is put together a little bit of a schematic so we can actually talk through what it exactly means with your correlation matrix coefficient. And by the way, your correlation coefficients will be, I'll be teaching how to do those in Excel in an additional presentation. But once you get a number from a correlation coefficient estimate, you need to figure out what the heck that really means, right? So let's say you get a number of 0. Your correlation coefficient is 0. What that means, as I discussed earlier, is there's no relationship. That means that as one variable goes up, the other one has no impact on the other variable. Zero indication that there's any relationship between those two variables. So no correlation is indicated by a 0. The direction of the correlation, there's two different directions, okay? There's positive and there's a negative correlation. And a positive correlation is anything greater than 0, so 0.1 essentially, all the way up to positive 1. What that means is as one variable goes up, so too does the other. And a negative relationship or negative correlation is anything from negative 0.1 all the way to negative 1.0. So that is a negative correlation, and that means that as one variable goes up, the other one goes down. So a positive correlation, as one variable goes up, the other variable goes up, and a negative correlation means as one variable goes up, the other variable goes down. Okay? So if we were going to say there's a positive relationship between, say, age and shoe size, that would make sense, right? So as you get older, your shoe size gets bigger. So as one variable goes up, as age goes up, your shoe size goes up. If you were going to say that the correlation between, say, number of years in school and the number of cigarettes smoked is a negative correlation, then what that essentially is saying is that as your number of years in school go up, the number of cigarettes smoked per day goes down, right? So that's the direction of correlations are positives and negatives. All right. So there's two things you need to know about correlations: the direction, positive or negative, and the second one is the strength. So whether it's weak or strong. And so in the bottom of the schematic, I have weak and I have strong. So the weakest correlation is the one closest to 0, right? Because that's no correlation to 0. The strongest one is the one furthest away from 0, either a positive 1 or a negative 1. And then in the middle, you have a 0.5. So positive 0.5 is a moderate correlation, and a negative 0.5 is sort of a moderate correlation. So it's somewhere between weak and strong. So while this is a quantitative measure in the sense that it gives you a numeric number, I do want to bring up that it's actually also very qualitative in the sense that it's hard to say, depending on your source, what is truly a moderate correlation or a weak correlation. But generally, it's understood that, it's not generally understood, it's well understood that as 0 increases to negative 1, you go from weak to strongest. As 0 goes from 0 to 1, you go from weak to the strongest being of the negative 1. Okay? So if you have a correlation of a 0.89, which is a positive correlation, 0.89 is positive, it would be somewhere around here, and that's a pretty strong correlation. If you had a negative correlation of a negative 0.7, be somewhere around here, it's a pretty strong correlation, negative correlation. If you had a correlation of 0.1, it's right around here, it's a fairly weak correlation. And if you had a negative 0.15, again, that's right around here, and that's also a fairly weak correlation. So picturing this on a graph, and sometimes it helps people to picture this stuff on a graph, The negative correlation, a perfect negative correlation, a -1, would be depicted as a line that goes in the top left all the way down to the bottom right. A perfect positive correlation, the strongest, if you in fact, would start at the bottom left all the way up to the top right. Okay? So, and the way we think about this is that as one variable goes up, the other variable goes up, right? So as one variable goes up, the other variable goes up. As one variable goes up, the other variable goes up. And you can follow that all the way up the line, right? So as this axis here, as we go up on this axis, so too do we go over on this axis. So up, over, up, over, up, over. So that's the positive correlation, and that's the strongest one right there, that line. It's pretty much the strongest you can have. The negative correlation is as one variable goes up, the other variable goes down, okay? So, as we go over on x, the x-axis is on the bottom here. As we go over on x, we go down on y. X, y, x, y. So, again, this is a negative correlation. It starts in the top left and all the way down to the bottom right, and it goes over right, down 1, over to the right, down 1, over to the right, down 1. And that is a perfect negative correlation. And a no correlation, if you graph no correlation between two variables, then, as I said earlier, the dots will be scattered at random. And looking just like this, they're scattered at random, and the line is perfectly horizontal. There's no indication that there's any relationship between those two variables.